Welcome to this video. This is the application of rules of exponents, meaning the product, quotient, and power rule, and we will be using both negative and positive exponents. So this screen shows a summary of the properties of exponents that we will be applying. I have separate videos for the product, quotient, and power rules, as well as an explanation of negative and positive exponents. If needed, please go back and watch them before you proceed. Example 1. State which rule should be applied. Then, simplify and write your final answer using only positive exponents in the box provided. So, in this example, we're only going to have one rule to apply. In all of the rest of the examples, there will be multiple rules of exponents that we will have to apply in a single problem. So, let's just enjoy this while we can. So, we just have one rule. So, if we look at part A, what rule should be applied? The product rule, quotient rule, or power rule? Remember, it's a good idea to pause the video, see if you're correct by making a guess, and then unpause it to check yourself. So the answer here is that we are going to apply the power rule. In other words, everything inside the parentheses is getting raised to the negative third power. So we have 2 raised to the negative third power, x squared raised to the negative third power, and y cubed to the negative third power. So, remember my advice. My advice is the very last step is to change your negative exponents to positive. So for right now, we're going to leave this guy alone. We're going to leave him as 2 to the negative third. We're not going to touch him. Okay? Then we're going to use the power rule. Remember, the power rule tells us to multiply 2 exponents when we have an exponent raised to an exponent. So 2 times negative 3 is negative 6. Same thing with the y. We have 3 times negative 3, so we're going to get negative 9. So now, I'm still not going to evaluate this. Instead, I'm going to rewrite it using only positive exponents. So, if 2 to the negative third is upstairs in the numerator and is unhappy, we move him downstairs to the denominator. Same thing with x to the negative 6. It becomes x to the 6th in the denominator. Same with y to the negative 9th. It becomes y to the 9th in the denominator. Notice there's nothing upstairs, so we just need a 1 upstairs to hold our place. So now, we can evaluate 2 to the third power. 2 to the third power is just 2 times 2 times 2. 2 times 2 times 2 is 8. So we have 1 over 8x to the 6th, y to the 9th. That is our final answer. Okay, let's look at part B. So we have 4xy divided by negative 16x squared y to the negative third. Pause this video and jot down what rule are we going to use? Product, quotient, or power? If you said the quotient rule, then you were correct. So remember, one way to help yourself with these problems is to write it as a series of fractions. So we have 4 over negative 16 times x over x squared, or x to the first over x squared, times y, or y to the first power, divided by y to the negative third power. So let's tackle this fraction. Remember, fraction is just division, right? And back in an earlier chapter, we learned how to reduce fractions. In this case, we can reduce by dividing numerator and denominator by 4. 4 divided by 4 is 1. Negative 16 divided by 4 is negative 4. So the first thing we have is that 4 over negative 16 reduces to negative 1 over 4. So that becomes negative 1 over 4. So the next thing we have to do is to apply the quotient rule. The quotient rule tells us to subtract exponents when we're dividing terms that have the same base. So we have x to the 1 minus 2, and then this is where you have to be really, really careful, right? A lot of students are going to write 1 minus 3. However, that is wrong. So see if you can figure out why that is wrong, or what is wrong with that. Well, the answer is that we actually have 1 minus negative 3. And 1 minus negative 3 is not the same as 1 minus 3. It's actually the same as 1 plus 3, because minus a negative is the same as plus a positive. So be very, very careful and to guard against those mistakes, because they're very frequently made. I see them all the time. Take a minute and actually write out the subtraction and use your parentheses. That's my best suggestion on how to guard against that mistake. Okay, so let's bring this down. We have negative 1/4. That hasn't changed. 1 minus 2, that's going to be negative 1. And then we have 1 minus negative 3, which we said is 1 plus 3. 1 plus 3 is 4. Okay, but we're not done yet, remember, because we still have to express our answer using only positive exponents. So I want to make a note here about this negative 1/4. Okay? That negative sign is not an exponent. So it's fine. We're going to leave it alone. It doesn't matter, right? Because the negative sign, making the negative sign positive, only applies if you're talking about an exponent. Negative 1/4 is a coefficient, so we just leave him all by himself. We don't touch him. Okay? So y to the 4th is happy. He's good upstairs, so we're going to leave him upstairs, right? He already has a positive exponent. To make the x happy, we're going to move him downstairs into the basement apartment, so it becomes x to the 1st power in the denominator. So I can write this a little bit more simply as negative y to the 4th power divided by 4x. And that's our final answer. All right, let's look at part C. Part C, again, pause the video, see if you can predict which rule we're going to use, and then unpause the video to see if you are correct. So the answer here is that we are going to use the product rule. So if you said that, then give yourself a pat on the back. So remember, with the product rule, we can use the commutative property of multiplication, which says that order doesn't matter. 2 times 3 is the same as 3 times 2. So first I'm going to start by rearranging these values. So I have 2 times negative 3 times x squared times x to the negative 4th times y to the 3rd times y to the negative 1st power. Okay? So 2 times negative 3, that's just simple arithmetic, that's 6. Then think about our exponents. The product rule tells me to add. So I have 2 plus negative 4, and then I have 3 plus negative 1. So 2 plus negative 4 is the same as 2 minus 4, which is negative 2. 3 plus negative 1 is the same as 3 minus 1, which is just 2. Okay, so I would be done except for, remember, we have to rewrite everything using only positive exponents. So the only exponent that I see that's negative is the negative 2. Again, the negative 6 is not an exponent, is it? It's a coefficient, so he's fine. We can leave him alone. So we have a negative 6 y squared. That is not going to move. It's not going to change. The only thing that's going to move is that x to the negative 2nd power becomes 1 over x to the 2nd power. Okay, so our final answer is negative 6y squared divided by x squared. Okay, so in this example, we only had to apply one rule, one exponent rule, to each problem. So now here's some suggested steps to simplify expressions when we're applying more than one term. So one thing you can do is what I call rearranging the furniture, and that's what we did here, right? I moved things around so it was more visually apparent which terms I could apply the rules to. Okay, so then you can apply the product quotient or power rule, right, once you rearrange things. And again, be careful with your constants. Avoid the temptation to apply the exponent rules with just the constants or coefficients. Okay. And so again, you can take a minute and read through this if you want. But again, remember the last thing I do is to change negative exponents to positive exponents. I apply all the properties of exponents first. So that's all kind of high level, very theoretical. Let's just get down to the next example and practice applying these steps. Okay, so like I said, the first thing I like to do, you don't have to, but this is what I like to do, is to move things around. I like to rearrange the furniture. So if I look at this expression, I can see, especially in the numerator, that it would be good to move things around so that it is more apparent what rules I can apply. So I'm going to say it's 4 times 3 times x to the negative 5th power times x to the 3rd power. Notice I'm crossing things off as I go so I don't forget anything or accidentally write something twice. Okay, then we have y to the negative 3rd, and then we have y to the negative 2nd power. Okay, another piece of advice that I will give you that I have found to be effective, even though it's mildly annoying, is to write the whole entire equation every time you do this, even though it takes a little bit of extra time. Okay, so again, even though it's annoying, I'm still going to write the denominator, which is 6x to the negative 5th, y to the 3rd. Okay, so now, what rule can I apply? Well, to me, the most visually obvious rule that I think I should apply is the product rule in the numerator. So 4 times 3 is 12. Okay, then we have x to the negative 5th times x to the 3rd. So we were going to add those exponents. So we have negative 5 plus 3. Negative 5 plus 3 is negative 2. Okay, so then we have our y values. So again, we're going to use the product rule. So we're going to add negative 3 plus negative 2. Okay? And again, it's a little bit tedious and annoying, but it can help you so that you don't forget that there is a denominator in this problem and fall into a false sense of security and think that you're done, because you're not, right? So we can still write the denominator there. Okay? And then also we have negative 3 plus negative 2. Let's go ahead and simplify that. That's going to be negative 5. Okay, so let's go ahead and put that in there, y to the negative 5th power. Okay, so now what can we do? Well, there's nothing else I can do to simplify the numerator by itself. If I look at the denominator, there's nothing I can do to simplify just the denominator. Therefore, I must have to graduate to looking at the quotient rule. So I'm going to have 12 over 6 times x to the negative 2nd power divided by x to the negative 5th power times y to the negative 5th power divided by y to the 3rd power. Okay? So let us start with our first term, which is just the coefficient, right? 12 divided by 6. So 12 divided by 6 is 2. You can always use a calculator if you're not sure. Okay? And then I'm going to do something a little bit different. I'm going to actually write out this subtraction. So remember, the quotient rule tells us to subtract exponents. So I do not have negative 2 minus 5. That is incorrect, so be careful. What I do have is x to the negative 2nd power minus negative 5. So negative 2 minus negative 5. So please, please, please watch your signs and be careful, or else you're going to find yourself with the wrong answer. So we have y to the negative 5th minus 3. All right, so now let's crunch some numbers here. Okay, so down here I'll do negative 2 minus negative 5. So minus the negative is the same as plus a positive. So we have negative 2 plus 5. That's going to give me 3. Okay, so far I have 2x to the 3rd power. Now let's tackle my y exponent. For my y exponent, I have negative 5 minus 3. That's going to give me negative 8. So I have 2x to the 3rd, y to the negative 8th power. It would be awesome if we were done. However, remember your directions. You have to use only positive exponents. So everybody is happy except for that y. He has a negative exponent. So to make him positive, we have to rewrite it as 2x to the 3rd divided by y to the 8th power. All right, let's do another example. So again, good strategy is to pause this video, right? See how far you can get without me, and then unpause that to see if you are correct. Okay? So the first thing I'm going to do is I am going to resolve this bit right here. So I have 3ab to the 3rd power quantity to the negative 2nd power. So the way I'm going to resolve that is it becomes 3 to the negative 2nd power, a to the negative 2nd power, b to the what? Well, it's going to be 3 times negative 2, or negative 6th power. Okay? Again, it's a little bit tedious and time consuming, but I'm still going to take the time to copy down the whole problem so that I don't forget about part of the problem. Okay? So that's the first thing I did, is I applied the power rule. Okay? And I did it to this part of the problem right there. Okay. Again, I'm not going to worry about 3 to the negative 2nd power. I'm not going to worry about evaluating it or reducing it or anything, just leaving it alone. All right. So the next thing that I want to do, and again, you don't have to do this, is I'm going to rearrange the furniture. Because if I rearrange the numerator, it's going to be a lot more obvious what rules can be applied. So I have 3 to the negative 2nd power, a to the negative 2nd power times a, or just a to the 1st power, times b to the negative 6th power times b to the negative 3rd power. Okay, and again, it's a bit tedious, but I'm still going to copy down my denominator so I don't forget about it. Okay, again, I'm just going to leave that 3 to the negative 2nd power alone. Okay, so the product rule is what I'm going to be applying here. The product rule tells me to add my exponents. So I have negative 2 plus 1. Negative 2 plus 1 is negative 1. Okay, then I have negative 6 plus negative 3. That's going to give me negative 9. Okay, and again, just copying down my denominator. Okay, so now I want to apply my quotient rule, right? So again, I'm going to ignore the constants, 3 to the negative second power divided by 2, just completely ignoring it, okay? So I'm just going to apply that product rule. Let's change colors here just for fun. Let's pick some nice colors. So purple's a nice color. It's my favorite color. So we have a to the negative first power minus negative 4. So be careful with your signs, right? The way I guard against making sign errors is I write out the work, okay? Then we have b to the negative 9 minus 0 power. All right. So let's see what we can do with this. So I have negative 1 minus negative 4. So remember, minus a negative is the same as plus a positive. So we have negative 1 plus 4. That's going to give us 3. Okay? So again, I have, oops, I don't need a negative sign there. I haven't done anything with my coefficient. I'm just leaving him alone. I'm still leaving him alone. He's just still hanging out there. So I have a to the third power, and then I also have negative 9 minus 0 is just going to be negative 9. Okay? So now is the moment everybody's been waiting for, which is where we take all of our negative exponents and put them in a different place, right? So if they're a negative exponent in the numerator, they're going to move to the denominator. If they're a negative exponent in the denominator, they're going to move to the numerator. So as you can see, my 3 to the negative second power is in the numerator. He's going to move downstairs. So he's gone, right? B to the negative 9th, he's going to move downstairs and become b to the positive 9. Okay, 2 is happy. He's a coefficient. I don't mess with him. I just leave him downstairs. So it's going to be 2 times 3 squared times b to the 9th. And a to the third stays in the numerator, as you can see, right? He's already a positive exponent, so we don't want to move him. Okay. So we have a to the third power divided by, now, finally, I can actually evaluate 2 times 3 squared. So don't forget your order of operations. Please excuse my dear Aunt Sally. So we have to do our exponent first. 3 squared is 3 times 3 or 9, and 2 times 9 is 18. So we're going to get a cubed divided by 18, b to the 9th power. And that's our final answer. All right, so now we have a huge problem, okay? And notice in the last 3 problems, right, I scaffolded this for you. I broke it down into steps. This time I'm not giving you any steps. The only thing I'm giving you is this hint, which is to start inside your parentheses and work your way out. Okay? Hypothetically, you could take this negative 3 and you could apply it to every single term in here. Okay? But if you do that, I'm just going to tell you, the probability of you making at least one arithmetic error is very high. The probability of me making at least one error is very high, and I've been doing this for decades. Okay? So, what we're going to do instead is we're going to start on the inside and work out. In other words, this negative 3, applying that to everything is going to be the last thing we do, not the first thing we do. Okay? So the first thing I'm going to do is try to simplify everything inside the parentheses. So my attention is being drawn to the numerator. So you can see that I could, as in previous examples, rearrange the numerator. So I have 3 times 6 times x to the negative second power times x to the negative 6th power times y to the 5th. And again, good practice is to cross these out as you go, so you don't write anything twice, or leave out a term. I've done that before. That's annoying. Okay, so then we have z to the 3 times z to the negative 3rd power. Okay, again, it's a little bit tedious and annoying, but I still take some time and I write out the whole problem so that I don't end up forgetting part of it and falling into a false sense of security, thinking that I'm done when I'm really not. All right, so let's do some math. Okay, so we have 3 times 6 is 18. Then we have the product rule. The product rule tells us to add exponents. Negative 2 plus negative 6 is negative 8. Okay, then we have, let's use this color. Our y's, again, product rule, 5 plus negative 2, or 5 minus 2, is 3. Okay. Then we have our z's. So we have 3 plus negative 3, which is z to the 0, which is just 1. So we really don't need him. We don't have to write him. So just pause for a moment and look at how much simpler, how much less terrible this looks already just by applying the product rule to the numerator, right? I've shrunk this down considerably. So hopefully that is convincing you to follow my advice and work from the inside out. Okay? Again, it's kind of annoying and tedious, but I'm still writing the whole problem, so I don't forget part of it. Okay. So look at this problem and see if you can predict the next thing that we actually kind of have to do in order to simplify it. So notice that x squared y to the negative second power, they're locked in, right? They're inside this parentheses, and they're all being raised to the negative third power. So if I want to do anything at all with this expression, I really have to simplify that piece of it. Okay, so again, it's tedious. I know it's time consuming, but it really does prevent mistakes. So I'm writing this whole thing over again. Okay, so we're going to have x squared quantity to the negative third power, right? That's going to give me x to the negative sixth, because we're applying the power rule here, which tells us to multiply those exponents. Likewise, we have y to the negative second power quantity to the third. Power rule, again, negative 2 times negative 3 is positive 6. Okay, so we close our parentheses and raise that to the negative third. So look how in 2 steps we have shrunk this problem down, way, way, way down, and made it much more tenable. Okay, so again, right, we can shrink it down even more. We're not done shrinking yet. It's good fun. Okay, so now I'm going to apply the quotient rule. And the way I like to do that is to rewrite things like as fractions, so that I can organize visually the terms that can be simplified. So I have 18 over 9. So 18 over 9 is 2. Okay. Then for x's, we have x to the negative 8 minus negative 6. Okay. I'm actually taking the time to write it out because otherwise I'm probably going to make a sign error. Okay, then we have y to the third divided by y to the 6, so that's y to the 3 minus 6. Okay, and again, all of this is being raised to the negative third power. And as you can see, I'm now out of room, so I'm going to go to the next page. Okay, so I have copied my problem down. So we have negative 8 minus negative 6, right? Remember, minus a negative is the same as plus a positive. So we have negative 8 plus 6, that's going to give me negative 2. So I have 2x to the negative second power. Then my exponent for y is 3 minus 6. That's going to give me negative 3. Okay? And again, this is all raised to the negative third power. So hopefully you can see that now if I apply the power rule with this negative 3, the probability of me making a mistake is much, much, much smaller than if I had applied it here to all of those terms inside the parentheses. So hopefully you believe me when I say this way is faster and easier. Okay, so we're going to go 2 to the negative third power. Then we have x to the negative second power raised to the negative third power. Then we have y to the negative third power raised to the negative third power. Again, I'm completely ignoring 2 to the negative third. I'm just leaving him alone until the very end. Okay, the power rule of exponents tells us to multiply. So negative 2 times negative 3 is positive 6. Negative 3 times negative 3 is positive 9. So now, let's look at our unhappy tenants. The only unhappy tenant is 2 to the negative third. Okay, so to make him happy, we're going to move him downstairs. So it's 2 to the positive 3 power in the denominator. Okay, so we have x to the 6th, y to the 9th, and 2 to the third power is 2 times 2 times 2, which is 8. So our final answer is x to the 6th, y to the 9th, divided by 8. All right, now example 5. So we have 5x to the 5th power divided by x raised to the negative third power. Again, remember my advice. Start inside and work your way out. So is there anything inside the parentheses that we could simplify? Well, actually there is, isn't there? Right? I have 5 times x to the 5th divided by x to the 1st power, right? So I could apply the quotient rule here. The quotient rule tells me to do what? It tells me to subtract exponents. Okay, so we have 5 minus 1. 5 minus 1 is 4. Now, there's nothing left to do inside the parentheses. So oops, I'm sorry, I dropped the negative sign there. Sorry about that. So we have 5x to the 4th power quantity to the negative third. So we're going to have 5 to the negative third power times x to the 4th quantity to the negative third. Okay, so I'm going to apply the power rule on the x. Again, just completely ignoring 5 to the negative third, just leaving him alone till the end. So 4 times negative 3 is negative 12. Okay, so now we will try to make our tenants happy. 5 to the negative third is unhappy. We move him into our basement apartment, so he becomes 5 to the positive third. X to the negative 12th is upstairs. He's unhappy. We move him downstairs into our basement apartment. It becomes x to the positive 12, and we put 1 in the numerator just as a placeholder. So we're almost done. We just have to evaluate 5 to the third power. It is 125. So we have 1 over 125x to the 12th power. And that's our final answer. All right, how about this one? So at this point, we've done a ton of examples. So hopefully at this point, you are pausing the video, working on the examples by yourself, and then unpausing to see if you are correct. So remember my suggestion, right? I strongly urge you to start from the inside out. So I'm going to start in the numerator, and I'm going to rearrange my terms, okay? So I have 3 times 4 times x to the 5th times x to the negative 5th times y to the negative 3rd times y times z. Okay, again, it takes a little bit of extra time, but it also saves me from accidentally forgetting part of my problem, so I'm still writing down the whole thing. Okay, so 3 times 4 is 12. Then I'm going to apply the product rule here. The product rule says to add exponents, so I have 5 plus negative 5, which is 0. So I'm going to have x to the 0 power, which remember is just 1. Okay, then for our y's, we would have negative 3 plus 1. So that's going to give us negative 2. So we have y to the negative 2nd power. And then the z stands alone, right? He's all by himself, so it's just z to the 1st power. Okay, again, I'm still taking a minute and copying down the rest of the problem so I don't forget that it is there. Okay, so let's write this a little bit more simply. So inside my parentheses, I'm going to have 12 over 2. Okay, my x is gone, isn't he? So if I wanted to write the x's, I would have to write a 1 over x. Hopefully that makes sense. Okay, my y's, there's a y in the numerator, y to the negative 2nd power, but there's no y in the denominator, so I can just put a 1 there. Okay, and then last but not least, I have a z to the 1st power upstairs, and I have z to the negative 2nd power downstairs. And again, all this is still being raised to the negative 3rd power. We're just kind of ignoring that for right now. All right, 12 divided by 2 is 6. Okay, 1 over x, we're leaving him alone. He's just 1 over x. Y to the negative 2nd power is y to the negative 2nd power. So the only math we really have to do here is z to the 1. Is it z to the 1 minus 2? Is that right? Nope, it's not. It's z to the 1 minus negative 2. Okay, and again, all this is being raised to the negative 3rd power. So you can see I'm out of room here, so I'm going to rewrite this on the next page. Okay, so let's look at our z. Okay, so we have z to the 1 minus negative 2. So 1 minus negative 2, remember minus a negative is the same as plus a positive, so we have 1 plus 2 or 3. So we have 6 over 1 times 1 over x. Uh-oh, I think I forgot a negative sign here. I'm sorry, guys. There's a negative sign here and here. I just forgot it when I copied it. So let's fix that. So we have y to the negative 2nd power over 1. Okay, and we just figured out that's just z to the 3rd. All right, so let's string this all back together. So we have 6y to the negative 2nd power, z to the 3rd power, divided by what? What's in the denominator? 1 times x times 1. So that's just x. So if you're wondering how I get from here to here, I'm literally just kind of doing this, right, and multiplying my numerator across and multiplying my denominator across. Okay, and of course we know this is all still raised to the negative 3rd power. Okay, so let's go ahead and apply that negative 3rd power before we get excited and moving or changing our exponents from negative to positive. Okay, so this is going to be 6 to the negative 3rd power, y to the negative 2nd power raised to the negative 3rd power, z to the 3rd power raised to the negative 3rd power, and then we have x to the negative 3rd power. Okay, once again, gee golly, I've run out of room. So let's continue on this page. Okay, so we have 6 to the negative 3rd power. Okay, then we're going to apply the power rule. Y to the negative 2nd power raised to the negative 3rd power. Negative 2 times negative 3 is positive 6. Okay, same thing here. We're applying the power rule. Okay, so that's going to give us z to the negative 9th power, and of course we still have x to the negative 3rd power in the denominator. Okay, so now is finally the time to take all of our positive exponents, leave them where they are. So the positive exponent is y to the 6th. Then we'll take all of our negative exponents and switch them. Okay, so 6 to the negative 3rd is in the numerator. If I want to make the exponent positive, I have to move it into the denominator. Likewise, z to the negative 9th power moves downstairs, becomes z to the positive 9th, and x to the negative 3rd moves upstairs. Oopsies, I don't know why I did that. It becomes positive. Okay, so the last step here is just to evaluate 6 to the third power. That's 6 times 6 times 6, or 36 times 6. Feel free to fact check me, but I'm pretty sure that is 216. So, did I do that? Yeah, okay, so we have y to the 6th, x to the 3rd, divided by 216, z to the 9th power. Okay, so we have one more example here. One more example. So again, see if you can pause the video and do as much as you can on your own before you need to check and unpause it. So we're going to start from the inside out. If I look at my numerator, I can see that there's work to be done here. So I'm going to rearrange the furniture. So we have 2 times 8 times x to the 12th power times y to the negative 2nd power times y to the negative 3rd power times z to the 4th power. I believe I got everything. Okay. Then in our denominator, okay, all this is going to be raised to the 3rd power. Okay, so I rearranged the furniture in the numerator. I wonder if I could do anything in the denominator as well. Since they're independent, they're separated, right? What do I need to do in the denominator? Well, in the denominator, I need to distribute that negative 3. So in other words, we're going to have 2 to the negative 3, x to the negative 3, y to the negative 3, z to the negative 3. So we kind of did 2 steps in one, and we can do that because the numerator is going to be evaluated independently from the denominator. Okay, so let's go ahead and simplify our numerator. So we have 2 times 8 is 16. Okay, so then remember this is the product rule. The product rule of exponents says to add them. 1 plus 12 is 13. Okay, same thing with our y's. Negative 2 plus negative 3 is negative 5. Okay, then we have z to the 4th, and then we're going to have 2 to the negative 3rd, x to the negative 3rd, y to the negative 3rd, z to the negative 3rd power, and all of this is still being raised to the 3rd power. Okay, so then I've done the power rule in the denominator. I've done the product rule in the numerator. So now we can kind of put the product and quotient, the numerator and the denominator together by applying the quotient rule. So we have to be a little bit careful here. I kind of got carried away. I was thinking it was 16 divided by 2, but it's not, is it? Right? It's 16 divided by 2 to the negative 3rd power. So we're just going to leave him alone, and we're not going to touch him. Okay, we'll just leave him be. But let's look at our variables. So we have x to the 13th divided by x to the negative 3rd power. Okay, what else do we have? We have y to the negative 5th power divided by y to the negative 3rd power. Okay, then we have z to the 4th power divided by z to the negative 3rd power. And again, all of this is still being raised to the 3rd power. Okay, so I ran out of room, so we're on a new page. Again, I'm just completely ignoring this thing. I'm just copying it down. I'm not going to mess with it till the very end. All right, so I strongly recommend that even though it's tedious and time-consuming, you take a minute and write out the quotient rule. So the quotient rule tells us to subtract these numbers. So do we have 13 minus 3? Is that right? No, we have 13 minus negative 3. Okay, same thing here. We have negative 5 minus negative 3. Be careful with those numbers, right? Then we have 4 minus negative 3. Okay, so be super, super careful with that. Okay, so let's go ahead and do this math. So we have 13 minus negative 3. Minus a negative is the same as plus a positive. So 13 plus 3 is 16. Then we have negative 5 minus negative 3. Again, minus a negative is the same as plus a positive. So we're going to get negative 2. And then last but not least, we have 4 minus negative 3. Okay, so minus a negative, again, same as plus a positive. So 4 plus 3 is 7. So we're going to have, again, leaving him alone, not bothering with him till the end, 16 divided by 2 to the negative 3rd power times x to the 16th, y to the negative 2nd, z to the 7th power. Again, all of this mess is raised to the 3rd power. All right. So normally, I would tell you, right, that we would still want to apply the 3rd power apply this before we make anything positive. However, I think it's going to make our lives a little bit easier if we make these positive first. And the reason is because this exponent is already positive, right? If this exponent was negative, then it would transform the exponents inside our parentheses. So let's rewrite this really quickly. Okay, so 1 over 2 to the negative third is going to become what? 2 to the third power. So we're going to have 16 times 2 to the third power times x to the 16th. While we're at it, let's fix him too. Y to the negative second power is going to become 1 over y squared. So we're going to have a positive y to the positive 2 in the denominator. Okay, and then our z to the 7th stays where he is. Okay, so again, you don't have to follow my steps. This is my recommendation. The reason I did that is because, why? Because now I can just do 2 to the third. 2 to the third is 8. Right, so we're going to have 16 times 8. And that's going to give us 128. So we have 128 x to the 16th, z to the 7th, divided by y squared, all raised to the third power. And once again, I ran out of room, so here we go. Okay, so we're going to have 128 to the third power. Okay, then we have x to the 16th quantity to the third power, z to the 7th quantity to the third power, divided by y squared raised to the third power. Okay, so this is the part of the show where we maybe want to use our calculator, which is totally fine. This is going to give us a ridiculous number. I don't know why I picked these numbers. I don't know what I was thinking. Anyways, 128 to the third power is 2,097,152. Don't ask me why I made this example with such a large number, but I did. Okay, and then everything else is just going to get the power rule, right? So we are going to be multiplying those numbers. So we have 16 times 3, that's 48. 7 times 3, that's 21. Did I do that right? Ooh, no, I'm sorry. That's a z. Z to the 21st power divided by y to the 12th power. Woo! So as you can see, that was how many pages? Good golly, 1, 2, 3 pages of work, right? We finally got there to our final answer.